Good afternoon, everyone. My name is Der Nicholas Rito, and now I'm going to present about natural language processing for phishing detection, a comparative analysis of SVM random forest and logistic regression. So for the overview, I will be discussing about the abstract, introduction, related works, objectives, methodology, result, conclusion, and reference. So moving on to the abstract, phishing remains a significant threat in email communication, aiming to deceive users through manipulative language. This study addressed the issue by implementing three machine learning algorithms such as SVM, random forest, and logistic regression on dataset of 5,796 phishing emails. Evaluation metrics used include accuracy, precision, and F1 score, with SVM achieving highest performance at 99.48% accuracy. To the introduction part, the internet has made communication easier, but it also brings new problems like phishing. So phishing basically is a cyber attack where attackers trick people into giving away personal or financial information, usually through fake emails. These phishing emails often look real and are hard to detect. In fact, reports show over 128,000 phishing emails in just one quarter of 2020, showing how fast the threat is growing. The study compares three machine learning methods such as SVM, random forest, and LR to find out which one works best for spotting phishing emails using NLP. Moving on to the related works, so for the phishing detection research, many studies have looked at how to find phishing, especially in emails. They often use ML and NLP to help. The main goal is to make phishing detection more accurate and reliable. To understanding about phishing, researchers like Suhair, Gupta, and Thakur studied how phishing works and how people are tricked. They say it's important to understand how attackers think and teach people about phishing. Some studies also mention that older methods didn't use NLP enough. And for the common datasets, some popular email datasets are basically used by researchers such as Spam Assassin, Enron, and Nasario. They include both real and phishing emails with text, links, and HTML. Also using NLP and ML. NLP helps find things like suspicious links and scripts in emails. Machine learning models like SVM, random forest, and logistic regression decide if the email is safe or phishing. Using both NLP and ML works well, but can still make some mistakes. And for the feature engineering part, important details in emails include keywords, links, and HTML. SVM and random forest usually work best. And choosing the right features like with G-square helps improve accuracy. And our main objective is to compare the effectiveness of three machine learning models, such as SVM, random forest, and logistic regression in detecting phishing emails. To enhance the accuracy of these models, NLP techniques are used to extract important features from email content, such as specific words, links, and script-based behaviors. The study also aims to identify which features contribute the most to accurate classification. Moving on to the methodology section, this study used a structured process to detect phishing emails using machine learning. The key steps are data collection, data preprocessing, feature extraction, model evaluation, classification, and model testing. And for the datasets used, the study used the spam assassin datasets, which contains a mix of legitimate and phishing emails. Table 1 presents three sample entries from the dataset. The first example, titled Architecture Crossover Trouble Solved, is labeled as ham, meaning it is a legitimate email. The other two examples, they are labeled as spam, indicating phishing or unwanted content. All entries are in CSV format and written in English. Reprocessing is required to clean the text with extensive processing applied to legitimate emails and minimal reprocessing for spam. This dataset helps train and test the model by providing real examples of both safe and malicious emails. For the methodology, in the data collection, the dataset used is Spam Assassin, which includes over 5,000 emails. It contains a mix of legitimate and phishing emails. Moving on to the data pre-processing, before training, the data is cleaned using these steps: remove stop words, punctuation and symbols, tokenize and lemmatized words to simplify text, and convert text into numbers using PF-IDF word embeddings. Moving on to the feature extraction, key features are taken from emails like HTML text, such as JavaScript, header information. Feature selection methods like Chi-square are used to keep only the most useful data. In the model evaluation, the dataset is split into 80% training and 20% testing. Three machine learning models are tested, which is SVM, RF, and logistic regression. Performance is measured using accuracy and F1 score. In the classification algorithm, each model is trained to classify emails as phishing or not phishing. SVM is known for high accuracy and low memory use. ML algorithms learn from patterns in the email content, HTML scripts, and metadata. In the final process, which is model testing, the trained models are tested with unseen data. I evaluate them using metrics like accuracy, precision, recall, and F1 score. Confusion metrics and classification reports are used to visualize the results and compare with baseline models. Moving on to the result, based on the data shown in Table 2, the performance of three machine learning classifiers, SVM, random forest, and logistic regression, was evaluated using 80-20 training to testing ratio. Among the three models, SVM achieved the highest accuracy of 99.48%, followed by random forest with 99.22% and logistic regression with 98.71%. In terms of F1 score, SVM was on last, while random forest and logistic regression stood at second and third place. Similarly, SVM achieved the highest precision at 99.62% compared to random forest and logistic regression. The conversion matrix shows how well the SVM model performed in detecting phishing emails. It correctly predicted 779 legitimate emails and 375 phishing emails. There were no false alarms, meaning it didn't wrongly flag any safe email as phishing. Only 6 phishing emails were missed. This proves that SVM is the best model compared to random forest and logistic regression. It had the highest accuracy, F1 score, and precision, making it the most reliable for detecting phishing emails in this study. For the conclusion, email is a big part of daily life, but phishing is a serious problem where people are tricked by fake emails. This study tested three machine learning models on 5,796 emails to detect phishing. The models were measured by accuracy, precision, and F1 score. SVM gave the best results with 99.48% accuracy, followed by random forest and logistic regression. And these are the three references that I used for my research paper, titled about email-based phishing attacks, communication channel under siege, a review of machine learning and deep learning methods for phishing email detection, and the last journal is about phishing email detection using NLP processing techniques, a literature survey. So I think that's all for my presentation, everyone. Thank you for your attention.